Hey there, space enthusiasts! Imagine a telescope so powerful it could capture the most distant galaxies and uncover mysteries that have been hidden from us for billions of years. Now, picture that telescope being built in one of Earth's most isolated places, the vast desert. In today's video, we'll dive deep into the journey of building a $1 billion megatelescope right in the middle of nowhere. Why the desert? What makes this telescope unique? And how will it redefine our understanding of the universe? Stick around to find out. Imagine a construction project that's truly out of this world. In the heart of a desert, perched atop a mountain, the largest optical telescope on Earth is coming to life. Standing nearly as tall as Big Ben, this telescope will soon capture images of distant planets with 15 times the sharpness of NASA's Hubble Space Telescope. It's about to unlock parts of the universe we haven't even begun to imagine. An astounding 16 nations have joined forces to make this feat a reality, something none could achieve alone. But how exactly do you build an extremely large telescope in one of the most remote locations on Earth? And how will it transform our understanding of the cosmos? Our story unfolds in Chile's Atacama Desert, which stretches nearly 1,000 kilometers along the Pacific coast of South America. Known as the driest place on Earth outside of Antarctica, it's a landscape of volcanoes, salt flats, and endless dust, a place so alien that the European Space Agency tests its Mars rovers here. And it's here, 3,000 meters above sea level and 150 kilometers from the nearest city, where humanity's vision of the universe is about to expand dramatically. Get ready for an unprecedented view of other worlds. Right here, at this very site, the European Southern Observatory, or ESO, is constructing what they've aptly named the Extremely Large Telescope, or ELT. Even though construction isn't yet complete, it's clear where the name comes from. This telescope is colossal. Its massive size is necessary to house an extraordinary mirror inside. Spanning 39 meters, this mirror is 4 times larger than those in the largest telescopes we have today. But that's only part of the magic. The ELT's system of 5 mirrors works together to collect 100 million times more light than the human eye. And while we'll skip the technical details for now, let's just say this setup will bring space into sharper focus than ever before. To shield this high-tech marvel from the elements, it will be housed inside a massive steel dome, clad in insulation and weighing over 6,000 tons. Towering 80 meters high and with a diameter of 93 meters, the dome has 2 enormous sliding doors that stay shut during the day. Underneath, 36 trolleys mounted to a circular concrete base allow the telescope to rotate a full 360 degrees. So, how did the construction team manage this incredible feat? How do you even start to build something as complex as this in such a barren landscape, hours away from civilization? Before any construction could begin, the European Southern Observatory, ESO, had to find the ideal location. They scouted sites in Spain, Morocco, and Argentina. But why did they ultimately choose this spot? The key was finding a location that could support the telescope's ambitious scientific goals. Roberto Tamai, the program manager for the ELT project at ESO, explains that numerous factors played into this critical decision. Considerations included turbulence, water vapor levels, wind patterns, and rainfall, he notes. Just imagine trying to operate a telescope in a place where you'd have to keep the doors closed half the time because of rain. Other crucial elements included ground stability, altitude, light pollution, and the clarity and darkness of the skies. Fortunately, the Atacama Desert checked all these boxes. In 2010, after extensive testing and data analysis, the decision was made, setting the stage for this groundbreaking project. After evaluating various sites, the team settled on a stunning location, the peak of Cerro Armazones Mountain. But there was a catch. Mountains tend to be pointy, and the telescope required a flat, level surface for construction. So, what was the solution? They decided to cut the top off. In 2014, the summit was flattened by drilling deep holes, filling them with explosives, and lighting the fuse. Once the dust settled, the rubble was cleared away, and a road was built to provide access to the site. However, this was just the beginning of their preparations, and challenges were already arising. During excavation, the team discovered that the mountain's center was made up of fractured rock and sand, not ideal conditions for a sturdy foundation. Because of this, it wasn't until 2019 that they could finally start laying the foundations and outlining the structure. But the surface material wasn't the only concern. This region is known to be one of the most seismically active on the planet. In footage from 2022, you can see a critical element of the design taking shape amidst the dust. To protect the telescope's delicate components from potential earthquakes, the ELT is built on a concrete base that's isolated from the ground. In the gap between the base and the ground, isolators are installed to absorb lateral and vertical forces during seismic activity. Have you ever looked up at the stars and dreamed of a career in astronomy, only to think it feels light years away? Well, that might not be the case. If you're ready to aim for the moon and gain the skills you need, this week's video sponsor, Brilliant, has everything you need to get started. Brilliant focuses on building critical thinking skills through hands-on problem solving, not just rote memorization. With thousands of interactive lessons covering subjects like mathematics, data analysis, programming, and AI, it's a fantastic resource for aspiring astronomers. Math is crucial if you want to study the cosmos, and Brilliant offers a wide range of courses for learners at every level from the basics to more advanced concepts. Plus, you can learn on the go. Whether you're diving into a new topic or doing a quick review, you can level up your skills in just a few minutes, even when you're short on time. Want to explore everything Brilliant has to offer for free for a whole 30 days? Just visit brilliant.org/Thebe1mm, scan the QR code on your screen, or click the link in the description. You'll also receive a 20% discount on an annual premium subscription. Now, let's get back to that mountain in the desert. By 2023, it was time to start on the dome, which consists of steel segments weighing as much as 70 tons each. To get these massive steel beams up the mountain, they started off as individual pieces that were joined together at a nearby base camp. From there, they were loaded onto remote-controlled transporters, which carefully carried them to the summit. Once at the top, cranes took over, piecing together the exterior like an oversized Lego set. But how did all these components make their way to this remote location in the first place? Thankfully, a lot of the infrastructure was already in place. Just over 20 kilometers away lies one of ESO's other stargazing sites, the Very Large Telescope, or VLT. Before construction began on the ELT roads, utilities, and all the essentials for running a scientific facility had to be built. This meant that the team only needed to extend those existing routes. While it was still a challenging task, it was far easier than starting from scratch. Now we can guess what you're thinking. They've already built the Very Large Telescope, and now the Extremely Large Telescope is under construction. Surely, it's only a matter of time before we hear about the ridiculously massive telescope or telescope endgame, right? While there's definitely a possibility of an even bigger telescope being built down the line, right now, the Extremely Large Telescope, ELT, is pushing the boundaries of size. But why is it capped at this scale? It all comes down to the mirrors. At 39 meters, that's about as large as you can go while still keeping costs manageable. The European Southern Observatory, ESO, learned this lesson firsthand when they attempted to create a telescope with a 100-meter mirror. Unfortunately, that project had to be scrapped because it became too complex and costly. And believe it or not, it was originally going to be called the Overwhelmingly Large Telescope. Yes, that was the actual name they considered. Now, you might find it amusing to think of an overwhelmingly large telescope, but it really was just a joke name. But let's get back to the Extremely Large Telescope. In 2023, the project officially reached its halfway mark. Along with the framework for the dome, the support cell, a massive lattice structure designed to hold the main mirror began to take shape inside. And like everything else associated with this project, it's absolutely gigantic. Just look at that tiny figure standing on one small part of it. Now seems like the perfect time to dive into those mirrors, which are nothing like the ones we use every day. These mirrors are much larger and more sophisticated, each with different shapes, sizes, and specific roles, all working together to make this ambitious telescope a reality. All these mirrors work seamlessly together to make the telescope function effectively. The main mirror, known as MONE, is the largest of them all, composed of nearly 800 hexagonal segments. Its primary role is to capture light from space and reflect it up to the second mirror M2 hanging above it. From there, the light travels down to M3 before bouncing back up to M4. M4 has a critical job. It corrects any distortions caused by atmospheric turbulence using a set of powerful lasers. Get ready to ignite the laser sequence. These lasers shoot into the sky, creating artificial guide stars that help the telescope gauge atmospheric blurring. This process, known as active optics, allows the ELT to make real-time corrections and is already in use with the Very Large Telescope. If you're still with us, thank you for sticking around. After the light passes through M4, it's directed to M5, where the image is stabilized before reaching the various instruments for processing. But enough about mirrors. Let's get to the big question. What does the European Southern Observatory hope to achieve with this groundbreaking device? In short, something truly incredible. The ELT will be the only telescope capable of capturing direct images of rocky exoplanets beyond our solar system worlds that might just have the potential to support life. Right now, you might be wondering why scientists would choose a desert to build such an ambitious project. Well, deserts have some of the clearest skies on Earth, with minimal light pollution and dry climates that reduce atmospheric interference. When it comes to studying the stars, every detail counts, and a dry, dark environment allows for the sharpest images possible. Plus, deserts have vast expanses of open land ideal for constructing massive scientific structures. This combination of natural and environmental factors makes deserts perfect for observatories, allowing telescopes to capture the night sky in unprecedented detail. Building a billion-dollar telescope requires advanced technology. This mega telescope is designed with adaptive optics, allowing it to correct for distortions caused by Earth's atmosphere in real time. It also features a segmented primary mirror made of multiple panels that work together to create one enormous reflective surface. These segments allow for flexibility and precision, improving the telescope's ability to capture faint celestial objects. Plus, high-powered sensors and AI-driven software enhance image quality and accuracy, making this telescope one of the most cutting-edge tools ever built for space observation. Constructing such a telescope in a remote desert isn't easy. The first challenge is transporting the materials and equipment to the site. Roads and infrastructure need to be built before the main construction can even begin. Then, specialized teams of engineers, astronomers, and technicians work together to assemble each part with extreme precision. This process can take years, with every detail scrutinized to ensure flawless performance. From installing the massive mirror to calibrating the technology, constructing this mega telescope is a testament to human innovation and perseverance. Once operational, this telescope could change the way we see the universe. With its ultra-high-resolution capabilities, scientists can observe stars, galaxies, and even distant planets in unparalleled detail. This means potential discoveries of Earth-like planets, detailed studies of black holes, and insights into the origins of galaxies. Such discoveries could help answer fundamental questions about the universe, questions we've been asking for centuries. The data collected might reveal clues about extraterrestrial life, the evolution of galaxies, and the nature of dark matter, pushing the boundaries of our understanding. The success of this mega telescope could pave the way for similar projects in other parts of the world. Imagine mega telescopes positioned strategically across the globe, creating a network that provides a comprehensive view of the cosmos. Additionally, advancements in telescope technology could lead to more powerful instruments on satellites and spacecraft, further expanding our exploration capabilities. This megatelescope isn't just a scientific project. It's a stepping stone to a new era of astronomy, where the universe becomes a little less mysterious and much more accessible. One of the key aspects of this megatelescope project is the collaboration between various institutions and organizations. This global effort exemplifies the spirit of scientific inquiry, where teamwork is essential to uncovering the mysteries of the universe. Funding a project of this magnitude is no small feat. Securing the $1 billion budget requires a mix of government support, private investment, and grants from various scientific organizations. There are constant negotiations and discussions on how to allocate resources efficiently while ensuring that the project remains on schedule. Potential investors must be convinced of the telescope's potential to yield groundbreaking discoveries that could benefit humanity. This financial backing is crucial, not only for construction, but also for ongoing operational costs once the telescope is up and running. As the megatelescope takes shape, there is a strong emphasis on educational outreach and public engagement. The project aims to inspire the next generation of scientists and astronomers through educational programs, workshops, and public lectures. By sharing the excitement of this groundbreaking venture, organizers hope to spark curiosity about astronomy and space science. Engaging with the public is essential, as it builds support for scientific endeavors and fosters a sense of connection between researchers and the communities that fund and support their work. Building a massive telescope in a desert environment comes with environmental responsibilities. Scientists and engineers must carefully assess the ecological impact of the construction process. This includes studying local wildlife, vegetation, and the overall ecosystem to ensure that the project minimizes disruption. Sustainable building practices are being prioritized, utilizing eco-friendly materials and energy-efficient technologies. By being conscientious about their environmental footprint, the team demonstrates a commitment to protecting the planet while advancing scientific discovery. The technology developed for this megatelescope is not just limited to its operation, it also has the potential to drive innovations in other fields. The adaptive optics system, for instance, could be adapted for use in other imaging technologies, from medical imaging to satellite surveillance. As researchers develop new ways to capture and process images, these advancements can lead to breakthroughs across various disciplines. The telescope could serve as a catalyst for innovation that extends far beyond astronomy, benefiting multiple sectors of science and industry. Artificial intelligence and machine learning are integral to the operation of the megatelescope. These technologies will analyze vast amounts of data generated by the telescope, identifying patterns and anomalies that human researchers might overlook. With the universe producing an immense amount of information, AI helps streamline the research process, allowing scientists to focus on interpreting results rather than sifting through raw data. As AI continues to evolve, its role in astronomy will become increasingly significant, enabling deeper exploration and understanding of cosmic phenomena. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.